Hey guys, and welcome to our next set of notes. Today's notes are going to be all about density, which is a measurement of the relationship between how heavy something is versus how much space that it takes up. So with that, let's get into the notes. Alrighty, so density, what we're talking about here today. So you can think of density as the measure of how compact some sort of material is. So it tells us a little bit about how close the atoms or molecules of a certain substance are to each other. So it's not just how heavy something is, right? It's about how heavy it is and how much space that it takes up. Right? So, for example, a piece of furniture like a couch, right, or a mattress, you expect it to be pretty heavy, mostly due to its size. It's a really big object. But if we have something a lot smaller that's the same heaviness, so say you have like, I don't know, a 75-pound weight or something that's only this big or so, that would be a lot more dense material because it weighs the same as maybe like a big couch or a mattress, but it's much, much smaller. So again, density is all about how big something is and how heavy that it weighs. It's those two things combined together to give us the density. So all substances in the world have density, whether you're a solid or a liquid or a gas even, you have a certain amount of density. Now, obviously, density tends to go down as you go from solid, which is usually the most dense, to liquids, which are medium density, to gases, which are very low density, but they still do have a certain density to them. So this idea of compactness, we can kind of see it in this little picture here. So these guys up at the top here, they are somewhat spread out. There's a little bit of space between all of them. And so we would call them less compact. And these would be less dense as well. Compared to all these particles down here, which are very compact, very close together, not a whole lot of space in between each one. So they would be more compact and also more dense. So the less compact, the more space that something takes up for its weight, that makes it more dense and more heavy in a smaller area. If something is less compact, it takes up less space. Wait, hold on, I think I switched that around. So if something is less compact, then it'll take up more space but have a lower weight. So that makes it less dense. If something is more compact, that means that it takes up less space, but it has a higher weight. And that makes it more dense. So density is, we can think of it as the amount of a substance, the amount of matter per some unit of volume. So per some area that it takes up. So it's what we call a ratio. So it's a ratio of mass to volume. Hold on, that color for my pen here. Mass to volume. So if the volume stays the same as the size of an object stays the same, but the mass gets bigger, we add in more mass to the same area, then we have the density increasing. So we have this mass over volume ratio. So if the mass goes up, that means that the density is going to go up as well. If our volume goes up, that means we have the same weight of something, but now it takes up more space than it was before. So it's less compact. It takes up more space for the same weight. Then our density is lower, because we're not as compact. We take up a lot of space. And so the more space that something takes up, the lower its density will be. So the formula that gives us density is this guy right here. Density equals the mass divided by the volume. So however much it weighs divided by how much space that it takes up. So the symbol for density could be, or the measurement for it could be in terms of grams per centimeters cubed, because that's weight versus a volume. It could also be grams per milliliter or grams per liter, which is also a form of weight. The main thing to remember, D equals M over V. Density equals mass divided by volume. So if you're doing this in like a calculator, for example, it would be M divided by V. All right, so when we think about mass, density, and volume, we can think about it in terms of this little triangle here. So the way that this triangle works is that you can cover up the portion of what you're trying to find, and the remaining two letters will tell you what you need to do in order to find it. So, for example, like we've been talking about, density equals mass divided by volume. So we have mass on the top of the triangle here and volume on the bottom of the triangle. So if we're trying to find density, then we could cover up density, and we would see that we need to do mass divided by volume in order to figure out what our density is. What about if we wanted to figure out the volume? So we know the mass and the density of an object, and we want to figure out its volume. Well, we do the same thing. We cover up the volume, and we see that we have to do mass divided by density, M over D, mass over density, in order to figure out what our volume is. Finally, if we know, or if we want to know what our mass is, then we can do cover up the mass and in order to determine what the mass is, we have to do density times volume. So if we want to figure out the mass of something, we can do density times volume in order to figure it out. So that's how this density, the DMV triangle works. By using this as our basic equation, density equals mass over volume, we can then rearrange the numbers in order to figure out density, volume, or mass of an object if we have the other two values. So remember this slide because this is going to be very important when we get to the homework. So like I mentioned before, everything has density. Gases have a very low density because they tend to be very spread out particles. Remember back when we were talking about solids, liquids, and gases. Gases have very spread out particles, so they're not very compact at all. And as we heat up gases, they actually get less dense because those particles move faster and faster and get further and further spread out from one another. So hot air is less dense than cold air. Cold air will tend to sink in an area and hot air will tend to rise. This is the reason why if you live in a house with 2 stories or you live on the second floor of an apartment, it tends to be a little bit warmer than the bottom floor because hot air rises and cool air drops. Same thing happens with a hot air balloon. So the reason why hot air balloons work is because they just heat up the air inside of this giant bag. So the air inside of the bag is hotter and less dense than the air outside of the bag. So the balloon will go up because the less dense air is going to rise. So cold air is more dense and will fall. Warm air is less dense and will rise. Liquids also have different densities. So like over here, the reason why we have these very defined layers in this beaker is because the liquids in here are all very different densities from one another. And so the most dense material will sink to the bottom and the least dense material will float on top. So this top has a low density, but the bottom has a high density. So in general, the more stuff is dissolved in a liquid, the more particles and chemicals and compounds are dissolved into a liquid, the more dense that it's going to be. This is why if you ever go swimming in the ocean, it's a little bit easier to float in seawater than it is in like a lake because all the salt in the ocean water makes ocean water a little bit more dense than fresh water. Just like air, colder temperature water tends to sink in an area and warmer temperature water tends to rise. So remember that if we combine things with 2 different densities, the more dense material will sink to the bottom and the less dense material would float on top. So what would happen if we had mercury, which has a pretty high density, 13,600 kilograms per meters cubed, and we have some lead, another very dense object that has 11,340 kilograms per meters cubed density. If we mix these 2 materials together, what would happen to them? So hopefully, by looking at these numbers, you can see the lead is less dense and the mercury is more dense. What this means is that the lead will actually float on mercury. So here we have an old school lead pool ball with some liquid mercury underneath it. And so this liquid mercury is actually more dense than the solid pool ball floating on top of it. So because of that difference in density, the lead is going to float on top of the mercury. So for the most part, solids tend to be more dense than liquids. There is one really cool exception to that rule, which is that ice is actually less dense than liquid water. And so this is why when you put ice cubes in your glass, they float up to the top. And it's why when water starts freezing in a lake or a pond, the frozen water will sit on top of the lake and doesn't sink down to the bottom of the lake because solid ice is actually less dense than liquid water. So solids have all sorts of different densities specific to whatever that solid is. So that's also the reason why icebergs float, is because ice has a lower density and water that's liquid actually has a greater density. So different factors can affect density. Like I mentioned with the gases, temperature is a big factor affecting density. The hotter temperature that something gets in general will make it less dense, and colder temperature tends to be more dense. This is especially true for gases, and is also true for most liquids, with water being a kind of weird exception. Pressure can also affect density. So in general, as you raise the pressure of something, you can increase the density because pressure can cause the material to be more compacted into a certain area. So think of like a oxygen tank that somebody uses when they go scuba diving. The oxygen is compressed into that tank due to the pressure that was used to get the oxygen into the tank and the pressure that the tank is exerting to hold the oxygen in place. So the oxygen in the tank is actually more dense than the oxygen in the outside surrounding environment because we essentially forced a lot of oxygen in there, which increased the pressure. Again, like I mentioned earlier, if you dissolve things into liquids, you tend to increase their density. So depending on what you dissolve and how concentrated it is, how much of it there is, that can affect the density of a material. So like I mentioned, ocean water, which has salt dissolved in it, tends to be more dense than fresh water because that dissolved salt adds to the density of the water. So here we have a density table of a bunch of different substances and their density over here. So you may notice that pure water has a density of exactly 1 gram per cubic centimeter. So we're going to look at a couple of these different materials and see if we think they would sink or float on water. So we'll just go through them one by one. Air, obviously that's going to float on water. If you ever put bubbles into the water, they immediately float up to the top and go out into the air because air has a very, very, very low density. Wood, also going to float on water because again, it has a density of 0.85 and water has a density of exactly 1. So that lower density means that we're going to have something that floats. Ice, like we already mentioned, is going to float. It has a density that's just below that of water. Obviously, things like aluminum, lead, and gold that have somewhat high to very high densities are going to sink. So these guys all have densities that are somewhat or much higher than 1. So any of these placed into water will sink down to the bottom for being more dense. What about ethanol down here? So ethanol is the alcohol that you normally get in your drinks. So things like wine, beer, liquor, the ethanol in there is the alcohol that you're drinking. Ethanol has a density of 0.94, which means that ethanol will float on water. This is why if you ever get a cocktail that has like a really high proof alcohol in it, that will tend to float up and sit on the top because of that alcohol that floats. And then methanol, which is an alcohol type used for more fuel-based stuff, will also float because it has an even lower density than regular ethanol. And that is everything that you should have to know about density. So hopefully that was pretty straightforward. The main thing that you're going to have to know for the homework is how to use that density equation, how we can calculate density, mass, and volume of an object if we're given the other two values. So let's take a look at what that looks like. Hold on, let me open it up real quick. Here we go. All right. Here we go. That's better. So our worksheet has 2 pages. They both essentially ask for the same thing. So for each problem on here, it'll give you 2 values of the density equation, and you have to solve the third one. Most of the time, most questions will be asking you to solve for the density. So you have to figure out what is the mass and what is the volume, and then do mass divided by volume. So we have an example right up here. So it says a student has a sample of aluminum that has a mass of 27 grams and a volume of 10 centimeters cubed. So what is the density of aluminum? So we know from our notes that density is equal to mass divided by volume. And so our mass was 27 grams and our volume was 10 centimeters cubed. So we do 27 divided by 10, and we get that the density of aluminum is 2.7 grams per centimeter cubed. So that's essentially what you'll be doing for every single one of these questions. You'll figure out what is the mass, what is the volume, and then do mass divided by volume in order to figure out the density. Make sure you pay attention to what the question is asking for, because they won't always ask you to calculate density. So number 1 and number 2 ask for density, but then number 3 wants to know the mass of an object given its density and volume. Number 4 wants to know the volume of a lead ball based on knowing the mass and the density. And then number 5 asks you to first calculate the volume of the block using the dimensions given, and then use that volume and the mass it gives you to calculate the density. Page 2 is essentially just the same set of stuff. It wants you to calculate the density based on the mass and the volume. It also might ask for what is the volume and what is the mass. And then number 5 down here at the bottom asks for, it gives you the densities and then says you have an unknown substance with this volume and this mass. And it's up to you to figure out what is the density, and does that density mean that it is aluminum if it's 2.7 or silver if it's 10.5. Hopefully that all should be pretty straightforward. As always, if you have any questions, please text me, email me, come to one of the Zoom office hours, or ask a question on the assignment page on Google Classroom, and I will get to answering it as soon as I see it. If you are ready to turn in the worksheet, you can write down your answers, take a picture of it, and send that to my text number or to my email, or upload the worksheet directly on the assignment page on the Google Classroom. So that's all for now. This is our last set of notes for the semester. I know, very exciting, very fun. So again, please reach out to me if you have any questions, and I will not see you guys for any more notes in the future because this is the last thing that we'll be doing. So good luck.